Okay, so this morning we are sort of completing the basic knowledge about JavaScript with something more specific to this language that are in particular objects and functions. Especially functions have a special behavior, but also objects. They are quite different from other programming languages. So that's what is more specific to this language here. Next week we'll start instead of working on how these particular features of function and objects work, especially with functional and asynchronous programming. Okay, so for today we still have the normal synchronous behavior, but we'll start to build some a bit more standard data structures. First of all, as I already mentioned last time, in JavaScript, objects are different from objects in other programming languages. In many other programming languages, an object is an instance of a class, basically. Okay? So you cannot have an object without having a class. And in JavaScript, it's not true. Basically, objects are independent entities. We can define classes for helping us creating objects, but an object is always independent also from the class it was created from. Okay? It has a life of its own. Classes are just an easier way of creating an object with some predefined template, but then they go on their own. So actually, most of what we see is how to manipulate objects, and then one particular operation for manipulating objects is creating them, and we can do that in 2 or 3 different ways. The simplest way, we'll see it already today, is called constructor functions. It's just a function that builds an object. You don't need to define a class for that. So, and objects are always dynamic. So an object can always grow some new property over time. So there is no fixed, okay, an object has been created with name, surname, and birth date, and all the objects of this type must have the same attributes and they cannot be modified. That's not true in JavaScript. Objects are always dynamic, so are very, very flexible from that point of view. There is literally no notion of encapsulation or privacy. Okay, in JavaScript, so every property basically is public, and it means that we don't need a getter or setter for object attributes and so on. So it's much, much simpler. On one hand, this creates more compact code. On the other hand, of course, it puts more responsibility onto the programmer, as always, in JavaScript. So the idea of an object is very simple. You just list a set of properties with some values inside braces, curly braces. And that will create an object with those properties and some value associated to those properties. Okay, so the creation of a new object is just braces. And then you can list the properties you want with a name for the property and the initial value for that. Okay, so that will create objects which are sort of entry tables with the names and values for each of the entries, for each of the properties. There are some tricks about how to name properties and so on that we see in a moment, maybe on an example. Okay. So let's imagine we create a person that may have a first name and is of type string, last name is my last name, city, for example, Turin. Okay, sorry. Of course, what we have in the right-hand side here can be any expression. In this case, they are just literal strings, but we could use variables. We could use any values computed in any way. And this could be person number 1. And if I have person number 2, we could have probably the same attribute. Probably we want to have the same type of attributes. Maybe Francesca, which will come here in the second hour. And maybe we forgot about the city. So every object has a different collection of attributes. It's our maybe responsibility or our desire to make them equal or not. Okay. In this case, in the second case, we don't have the city attribute. There are 2 independent objects, and what we can do with them, of course, is to modify, extract, and manipulate their properties. Okay, so if we want to see what they look like, we can print person 1, person 2, and see what happens here. And we see that it printed some representation of the object. Of course, the object can be serialized, and you can expand to see the properties. The same we can do in the debugger there. Okay, I put an empty console.log at the end of the last statement with a breakpoint, so that the program will stop in debugging mode, will stop before destroying all the variables, and so we can expect what happens. Okay, it's a stupid debugging habit. And the same is for the second object. Okay, but then we can, if we want, of course, we can modify and access or modify. So for accessing the properties, of course, we can just use the dot notation. So I want to just list the name, the names of these people are maybe person 1 dot first name plus maybe, let's put a space, person 2 dot first name. And this creates a variable called names that we see here with the concatenation of the names. So accessing the property, we don't need any getters or other methods. We just list the property name and with a dot notation. But what happens is if I try to access a property which is not there. So for example, we know the city 1 is defined, but maybe the city 2 of the city attribute of second person is not defined. Okay, so what happens if I try to access it? I'm trying here to access an attribute which is not there, which is not defined. Okay, so before try to print it or doing something with this value, let's see what happens here. What is the value that we are reading here and storing in city2 is, as always, undefined. Okay, so what in other languages could create an exception, an error, here just returns undefined as a value. Okay? Maybe we want to check for that. Maybe we need to handle that in some way, because if we are using, inside the function or whatever, some object, we expect some attributes to be there. In some cases, depending on where they come from, these attributes could not be there. So we have a notion, say, of optional attributes of an object that you can dynamically check at runtime. So what we could do is say, okay, but if the city is not defined, we could set a default value. So it's very common to have values that we are not sure they are defined or not, and so we want to set a default value for overriding the undefined. Of course, we could do that with an if statement. If person2.city is undefined equal to undefined, then city2 equal to unknown or to Turing maybe. Otherwise, okay, use the value. But there are shortcuts that we use quite often. One shortcut that we use very often is the OR operator. Let's say Rome, I don't know. So in this case, if I run it again, the city becomes Rome. How does it work? And of course, if I do the same with the first city, where the attribute is normally defined, of course, I get the right city. So that's the idea of default values. I take the actual value if it's defined, otherwise I take a default value. This is quite common, and how does it work? It works because this is a Boolean operator, the OR operator between true and false and so on. And the rule by this is working is that it's an OR operator, so if the first operand is true, or in JavaScript we say is truthy, so any value that converts to true, we don't need to look at the rest. So actually, the definition of the OR operator is if the first operand converts to true, is truthy, then the result of the operator is the first argument. Otherwise, if it's falsy, the result is the second argument. It's not true or false. The result of an OR statement of a Boolean operator in JavaScript is not true or false, but it's the first or the second value, according to whether the first value converts to true or false. And with an AND statement, it would be the same. If the first argument is false, then return the first argument. If it's true, return the second one. Because we need to look at the second one only if the first argument of an AND is true or the first argument of an OR is false. Okay? So this is a trick that can be used often to set default values when we are not sure that we have a real value. And the only problem here is that the left-hand side of the and you see a lot of code like this, okay, around. So there seems like strange tricks, but in the real JavaScript code, it happens very frequently. So it's worth, learning the habits. The issue is that undefined is one of the possible false values, but it's not the only one. Okay? So, for example, if I had here an empty string, I need a comma there, this would not work, because the end, or say, I'm trying to say, I don't want the city. City, I explicitly am saying which is empty. Okay? I didn't forget the property. It's an empty city, for some reason, maybe not the city, but what happens is that the empty string is considered false, and so even if this attribute is not undefined, is defined as an empty string, this empty string converts to false. And so it's treated, so we cannot distinguish with this syntax between a missing argument and an argument that is 0 or the empty string. Remember, we have this handful of elements that converts to false, and 0 or empty string could be real values, valid values. And so in this case, we are confusing a missing value with a real value that happens to be 0 or happens to be empty string. This is why, okay, for this reason, JavaScript has another operator just for this purpose, mainly for this purpose, which is the double question mark. It has a strange name. It's called the nullish coalescing operator. Okay, I don't care about the name. What happens is that it behaves as before, but only if the left-hand side is really null or undefined. Okay? Checks if the first argument is null or undefined. Only these two values, null or undefined, not for 0 or empty strings. So in this case, since we have this attribute on both objects, we see that the second one, we found that the attribute is there, is the empty string, but it's not undefined, it's defined as the empty string, so we don't replace it with the default value. So it can be a useful way when we are making big expressions and we are not sure that all the values are defined or some are null, just to use this operator, say, okay, if it's null, just use this value. Also, when you read from a data structure, you don't know whether this value is there, you can just put a default value there, which is sort of trying to compensate for the fact that the properties of an object are dynamic. Another issue is the simpler one, you usually will try to avoid, the names of the properties. Okay, we define some names and some values. In this case, the values are strings, could be anything. A value can be an array, can be another object, can be, okay. Of course, for the value side, we have no limitation. From the property side, we just listed here some identifiers, freely. First name, actually, these identifiers could also be more complex. For example, let's imagine I want to list a work city, okay, the city where I'm working, maybe Turin again. And in this case, this property could have a space in it. So this is not a valid identifier, of course, it will give us a syntax error. That's why first I use an underscore there. There is a way around that, which is actually using quotes. So any string can be a valid property name. If it contains some characters that are not valid for an identifier, we just use the property name as a string. We try to avoid that because it's less useful, but we see that the property name is still the same, even if it contains some spaces or some other type of characters. If it happens, for creating those properties, we have no issue. We just put them in quotes. But how do we access these properties? Okay? So this syntax here is becoming strange because const world city person1 dot work city. I cannot, of course, write this from the syntax point of view, because this will be a string. Is this a string or is this a property name? So actually what we should do is to use an alternative syntax for accessing properties, which is square brackets. So in any object, we can access a property by using the dot notation, which is more familiar, easier, or the bracket notation. In the bracket notation, of course, the argument should be a string, and this string should match a property name, a name of a property of the object. Okay? In this case, we see that inside the brackets we have a string. This string could also be computed by an expression. So this is also a way of using or generating dynamic property names. And the same can also be done in reverse. We can also use this notation to create new properties with different names. Let's see an example in a second. Okay, this is just what has been told. We'll play together. Okay, so we can have properties that are just names that are complex strings. Values can be strings, can be numbers, can be other more complex objects. For example, here we have an array. Of course, we are nesting values inside. Okay, and for accessing, we can use the dot notation or the bracket notation interchangeably. Since the bracket notation exists, we can also think, in some cases, to use the objects as cheap associative arrays. Okay, so imagine you are building a small, phone book, and you want the phone book would associate some names to some numbers, to the telephone numbers, for example. Okay, so we could have a phone book that starts as an empty object, and then we can add elements to it. Okay, so we can say that the phone book, my number is maybe 1234, and another person's number is all nines. So the syntax looks like we are using an associative array, what, for example, Python calls dictionary, something with a key, which can be any value, and a value mapped to it. Okay, and actually it works. And if we see it, we see that this phone book is an object with two properties, the property name and value, property name and value. Okay, and this, of course, is not a real map data structure. If we want to do something serious in the JavaScript library, we have an object called map that does the right thing, that supports any kind of key type. In this case, the key value must be just a string. You cannot do anything else as a key. But in some cases, it can be just a cheaper way of storing some value, just by using the fact that properties of an object are dynamic, so we can add a property anytime, even after the object has been created. So I created an empty object here, and I'm adding properties there. Of course, I could, sorry I didn't see the example, I could also do that before. So for example, before I could, after the object has been created, we could also, for example, say, okay, we have I don't know, age unknown. And we add a property like that. Even if it was not there, we just add in any time in a normal property. Or just we exploit the fact that properties can be added at any time. And the name of a property, which is a string, can be also computed by using, so any value computed by using the square notation. We can also use them in this way. And so we have a double duty, just object as value, as key value containers, or objects as real, a type of new value. Another issue is that for which we always see, sometimes we see strange syntax, is what happens with the nested properties. Okay, for example, in our person, we just had the city, but we may have need to have some more information. So maybe we want to have a property which calls the address, and the address on its own is an object with, for example, the city itself, which is Turin. It can be the street, which is Corso Duca, which is the number, 24, and the post code, which in Turing is 129, and so on, okay? Okay, no problem. If I want to, in this case, check the city, I have the address, which is a property of person 1, that maps to an object, and on its turn, this object will have a property which is called city. So we can easily, let's do that before the phone book, we can easily write my city as person 1 dot address dot city. And if we run it, of course, my city becomes Turin. Nothing strange here, but what happens if I try to do that with person 2? Okay? So this will be my city 1. We try to do that with my city 2 by extracting the city from the address of the person 2. Of course, we know it's not defined. We didn't define it. So if I had, let me stop here, read person2.address, I know that my city2 in this case would be undefined, right? Yeah, because address is not a valid property. And we already know how to set a default if you want, okay? But the issue is, I don't need address, which is an object. In this case, I just need the sub-property, city. I expect probably, I don't know, to get an undefined value, because the city is not defined. The issue is that I not get the undefined, I get an error here, one of the few cases in which JavaScript throws an error, cannot read properties of undefined. Yes, because this expression up to here is computed as undefined. And so we are doing undefined.city. But undefined is not an object. It's a different type. Now, remember the type system, we have a number, a string, array, null, undefined, and object. They're two different things. So undefined is not an object of type object. And so it doesn't have properties. You cannot try to extract it. It's not any object. Let me make another example. If I try to make a stupid object and extract city, it doesn't create any error. It returns undefined. It's an object without that property. But the problem is undefined is not. And so what you find is that, oh, but I need also to protect this access. If I don't want an error, because I know that the property could be present or missing. And I just want to get undefined or a default value in that case. What should I do? Okay, somebody can suggest this kind of chain. So with a chain of ANDs, remember how the Boolean AND is working. If the first element is false, then return the first element. Otherwise, go forward and return the second. So in this case, his book was undefined, just return undefined. Otherwise, if the book is defined, just check if book.author is undefined. If it's undefined, then return undefined. Otherwise, return what we have on the right, and so on. So we go forward only if we find values that are all not falsy. Again, here we have the issue of the empty strings or the zeros that can be confused with the undefined. And so in the more recent versions of JavaScript, we had this, sorry, I always remember, question mark dot operator, which is an access property where if the object that we are trying to access property is undefined, it just returns undefined. Otherwise, it goes forward and gets the value. Okay? So in this case, we are, my city2 is actually undefined. We tried to access it. We didn't find, in all the sequences of sub-properties, at some point we didn't have anything. And so the whole evaluation just stops there and returns undefined. Now, if I want, I could put a default value of all the expression. Okay? So it's something that we are not used in many other programming languages because either the property is there or it's a programming error. Okay? But here we'll see that we are dealing with objects whose properties are dynamic and also depend maybe on some user input or some result that we can from another function. So it's good to be able to reason also with missing fields. And if we don't know which properties are defined in an object, how can we use this object? We cannot just guess a name, okay? Person.age, does it exist or not? We cannot just guess, okay? Or birth date. And so there's a way of extracting or listing the property of an object. Remember last time I told you to use the for of construct for iterating over arrays. We also have this for in that iterates over the properties of an object. So we don't know which properties we have. With a for in, we can list them, enumerate them. Or even easier, probably, is to get an array with the list of properties of an object with the function object.keys. So after putting and removing keys and so on for an object, I want to know what keys do they have. We can just use this function object.keys that lists me all of them. And so I'm sure I know. For example, all the people for which I have a phone book item can be just object listed by extracting the keys from the phone book object. Especially when we are using the, what is that, phone book here, no, console here, in the sprint. And in this case, it's an array with the names of the keys of that object. Especially when we are using objects as associative mappings, it can be useful just to get the list of keys so that you can iterate over them, or count them, or do anything else. Or, of course, we can use entries to convert any object to actually a list of pairs, key value pairs, and so on, and then we process them as arrays. So there's these ways, especially when we are working with highly dynamic properties. Okay, another issue is copy versus aliasing, what we already saw last time with arrays. Okay, if we make just an assignment of a new object, a new variable from an existing object, it does not create a copy. It just creates a new reference to the same object. For example, this picture will help us understand. In this case, I have an object, book, that was this yellow table here, and we make a new variable, and this variable will refer to the same object that is currently being referred by the variable book. So we have two different variables that point to the same object. And this means that if I try to modify the author of book, it will also modify the author of book number 2. Okay? So if it's not what we want, if we want what we want, okay. And this works, for example, when we are passing a parameter to a function. The parameter, the arguments, the objects and arrays are always passed by reference. I'm giving you a new reference to an existing object so you can modify it if you want. Okay? But if we want to really to make a copy, there are a few ways of doing that, of creating a new object with the same keys and the same values. Okay? One ugly syntax is this one, object.assign, but we won't use it. We will use, this other syntax with the, again, the spread operator, the 3 dots operator. Let's do that with an example. So let's imagine that we have and we want a copy of person 1. Okay, the easy way of making a copy is to create a new object that is constructed by taking the properties of person 1 and exploding them with the spread operator and putting them together into a new object. So always imagine this 3 dots operator as taking the content of the array. Tuesday we were talking about arrays, today we are talking about objects, taking the elements and listing them there, comma separated. And then we are putting them into a new object. Okay, so this is an easy way, an open brace always creates an object. A new one, we are not reusing the same object. What we are doing is that we are reusing the contents of the object itself. So in this case, if we run it, we see that, okay, person 1 copy, of course, contains, is identical to person 1, and the copy is here. Also with the address and so on. And in this case, if we change something on the copy, of course, the main object will not, the first object will not be affected within limits. Person1.copy, for example, if we want to set what we had here as a property, the city, could be Rome, for example. And if I run this program again, I will see that person 1, of course, keeps the city as Turin, but the copy gets the city of Rome. So these 2 objects are totally independent. The second one was initialized with the first. But this only works for first-level properties. The address property is a complex property, is an object in itself. So when the spread operator takes the values of the first object, it takes the references to those values. And if those values are objects, it will share the reference to them. So it is what we call a shallow copy. I copy only the surface. We are not going deep to copy everything. And we see that if we try to modify person 1 copy dot address dot city, and we make it New York, which is perfectly good, perfectly valid. We see that, of course, the person copy, we have the city property, but inside address, now we have city New York. But what happened is that also in person 1, the address field is New York, because the address field is an object, and in creating the new copy, we just made a reference to that object. What we did here, just to be aware with this instruction, is equivalent to saying person 1 copy, take a new object, and then copy the name, first name, from person 1.firstname, and so on. Okay? We are copying each property into the new object. We are creating a new object and copying the property inside. But it comes a time where we do the copy of the address. So in the first case, this was a string. We are actually sharing a reference to the string. Okay? We are not making a copy of the string with my first name. We are sharing that, but since strings are immutable, we don't see the difference. The same for numbers. When we are copying the reference to an object, actually that object could be modified, and in this case the modification is shared. So if we want, if you really need, you need to go deep into the property and make a copy of the address and then recreate the object itself. It's not very common, but just be aware that this operation is only for shell and copy. All these issues about modifying shared copies and so on is also one of the reasons why in JavaScript and in functional programming in general we tend to only work with immutable values. I create something, if I need to modify it, I create something else, and while creating it, I will modify it. Just so we don't need to keep track of which is which object shares with other. By the way, this syntax is also useful if we want to make a copy with modifications of an object. And for example, I make two examples that copy A and copy B, where I could write, let's use city, like this. So once I'm creating a new object, I can mix explicit properties and properties taken from other objects, so spreading other objects. We can also use that from merging the properties of two different objects into one. And this is processed left to right. Yes, left to right. And so they have different meanings. The second one is a default. The final object will have a property called city if the person one doesn't have it. Okay? Instead, if the person one would already have a property called city, it will be overwritten, and the final value will be that of person one. Left to right. I set a property called city, later on I find another property called city, it will take over. So I want the final object to have some property. I'm not sure whether the object I have already possesses the property. I can set a default value like this. And in the other case, we are overwriting something. So in the second case, Paris will never appear because person one already has that value. Okay. In the first case, we are ignoring the city of the object and overwriting that with Paris. Well, we are not really ignoring. We are copying it, but then later on we'll have another attribute with the same name, and it will just overwrite that. So it's a way of, okay, make me a copy of this object, but with a new value. So again, there are ways of doing that with more lines of code, but these strange operators, these question marks and these spread operators are very useful just for manipulating objects, like we manipulate arrays with concatenation and something like that. So that's why objects are very, very easy, very cheap to create. Just open a brace, you don't need to define a class, anything, to define a getter or setter, just use it. Right now, we only saw objects that contain numbers, strings, other objects in the slides, an array, and so on. What will become very powerful is when we start working with objects that contain functions. In object-oriented programming, you could call them methods, so a function associated with an object instance. okay? And that will be just a special case of an object property. So this brings us to functions. The concept of function is not strange, not new in JavaScript, but again, also here, the function is a very dynamic object. Functions are normal, in many cases treated as normal objects. You know, when you have an array, what can you do with the array? For example, accessing an element. So you can index the array with a square bracket. When you're a function, what can you do with a function? You can call it with the round brackets. When you have an object, you can access a field with a dot notation. So it's a normal object that happens to have type function, and since it has type function, you can call it. So you can call something that behaves like a function that, I don't know, you defined in some strange ways. Okay, we'll see that. The basic concept of a function are classic. You can define a function with this kind of syntax. Function, name of the function, parameters, body of the function itself. This is the classical definition that you find in all the other languages. Of course, JavaScript is not a typed language, so you don't have the type of the arguments, you don't have the types of the return value. Okay? So you use just the function keyword. Let's make maybe a new file for these examples. Functions. So that we can play with them. Okay, so maybe we have a function, we can call it square, maybe, that takes an argument x and returns the square of that value. Very mathematically advanced function. Like in any other programming language, so you can take a value y, make it 7, and then compute the y2, which is the square of 7. That would be probably 49. And this shouldn't surprise us if it works. 7 and 49. So, normal syntax, function, the keyword, the name of the function itself, square. The argument list, in this case, we could have 0 argument, 1 argument, or many arguments separated by commas. Inside the body of the function, of course, the argument is initialized with a reference to the actual value, and we can use it inside, like it was a local variable. Of course, inside the function, we can define our variables if we need. Okay, inside, we can do anything else, and we can, if we want, return a value. If we don't return a value, the function returns, guess what? Undefined. So a value is always returned by a function, either my explicit value with the return statement, or undefined, which is a value. So it never happens to have a function that don't return values. Okay, that's the basic part. Okay, like we said, in the function call, the argument is passed by reference. So it's an object. In this case, it's an object of type number. We pass a reference to this object. So the object 7. So I could write y here, not 7. The y outside the program, the function call, and x inside the function call are the same object. They point to the same object. Okay? In this case, it's a number, so it's immutable, it doesn't care. But if y was an array, was an object, they would share the same object. So if the function modifies the object or the array, the object will be modified also in the main program. Okay? Just be careful about that. If we focus on this line here, what we have? We have a square, which is an identifier. This identifier points to an object of type function. You see, square is one variable, like the other variables that we have in the program. The type of the variable is function. So a function definition simply creates a variable with a value of type function, instead of a value of type object or array. And so here, at line 8, we are taking a variable that points, refers to an object of type function, and we are using one of the permitted operations on function, which is calling them. If you want, I could also define a new variable like this, and call this function with this strange name. It's getting ugly, but don't worry, it will become uglier. So I define a variable, I define a function, sorry. With the keyword function, I'm defining a new function. The function is everything except the name. This is the function. We create it, we store it somewhere, and we make a variable to point at it. We call this variable square. That will be just a variable pointing to a value, that value being a function of function type. This variable can be used, you can store it into an array, into an object property, you can copy it, whatever. This doesn't create any problem, doesn't call the function itself. It's just a variable with a value. I store this value somewhere else. I don't care whether this square points to a function or an array or an object or whatever. It's just a number, a value, sorry, a reference. And here, W, I don't know what it is. Let's not look at the first lines. I don't know what it is. Nothing tells me that W is a function. It's just a variable that points to an object, and if the type of this object is a function, it can be called. Parentheses, we call the function. Which one? The one that W is currently referring to, which is the same that square was, or is still referring to. Now, if I run this, you see that square and W are the same function. Also, W is points to an object of type square that contains exactly the same code. Well, it is exactly the same code. It's not a copy. So this puts in our mind that function names are just variables. And functions themselves are objects that can be stored, moved, and sometimes called. That's why there are also different syntaxes for defining functions. The first one was just a function declaration. We call it function declaration, the classical one. But the equivalent one, an equivalent method could be just to define a variable, let's say the third power, and assign a value of type function to this new variable. So we need to create, in JavaScript, we have a possibility of creating a function as an expression. If you want to create an object, we use braces. We want to create an array, we use brackets, or whatever you call them. We want to create a function, we just write function A, and then we put a body, a return maybe a times square of a. But we don't need to write it only in one line, of course. So the syntax is similar. We still use the function keyword, but in a very different way. Here, function is a declaration, is a statement for declaring a function, and assigning the resulting object to a variable square. Here, this is just an expression, like 3 plus 2. The expression creates a new literal object of constant object of type function. And we can use this function immediately or store it somewhere to use it later. Okay? And so later on we could say, okay, this was square. Maybe y3 is the triple power of y. And once they are created, there's some error here, triple is not defined, third power. Once they are defined, they are indistinguishable. Square is an object of type function that points to that function declared in this way. Third is a variable, it's not an object, a variable that points to an object of type function. They are the same. Okay. The second one is defined as an expression. By the way, this function doesn't have a name on its own. You see here in the debugger, it's a function f, while before we have f square. And also with w, we had f square. Okay? This square, in the case of function declaration, also becomes the label of the function. But it's only for debug purposes, because during the code, we don't care with that. We call it w, it was square, but this square was not used anymore. In this case, we don't have a name. So it's just a function. Does it need a name? No. It just needs a variable that points to that object to be able to use it. By itself, it doesn't need a name. If we want, we can give it a name, okay? We can also write it here. But it's just for debugging purposes. This name that we put here is never used. Okay? So I'm not so sure it's a good idea to put it, because if you write something different from the name we call the function, we could get confused. But it can be there, maybe for documentation, for clarity, or whatever. And okay, so this is more explicit. We are doing the same thing, creating a function object, but we see that this creates a value that is stored into a variable. Imagine being inside a function that can create another function and return it. It's just an object. So while the first version is static, you declare the function when you reach that line of the code. In the second case, it's just an expression that you can evaluate also many times. And every time you evaluate this expression, it will create a new function. Sorry, a new object of type function. And you can do whatever you want. Your question in your mind will be, why would I want it? Okay? Why would I want to create dynamically many functions? Oh, we'll see that, we'll see that. We'll come to that next Tuesday. But technically, we just should make peace with the fact that functions are just objects like strings. There is also a third syntax, which makes it even more explicit and even more, say, compact, which is a different way of creating a function expression, which is called the arrow function. using the arrow operator, this one, equal, greater than, which is not greater or equal, okay, it's equal, greater, it's an arrow, that creates a new function. So it takes a while to be able to find it in the code, okay, because it's a very strong, it's a small symbol, but it's very strong meaning. Creates a new function. So for example, I want to create a function that computes the fourth power, okay. The fourth power is a function. So instead of the function keyword, I write the arrow symbol. Before the arrow, I list the arguments. Let's call it base. I change the names every time so that and the body of the function is on the right-hand side, maybe square, base, times, or square, for example. And this is the same as the function expression. Nearly the same. There's some details about this statement, how this keyword behaves, but not for today. It's much more compact, sometimes less visible. Of course, it's very shorter, much shorter. And it works in the same way. Y4 is a fourth power of y. Let's print it to be sure. And of course, these are the powers of 7. And we see fourth is a function, again. It's a variable that points to an object of type function. It's defined with a different syntax, with the arrow syntax instead with the function syntax. But it's the same. Since it's very compact, we will use it a lot. Okay? The function definition, the definition of the function object is actually that one. Okay? Then what do we do with this? And it creates an object and returns a value, a reference to that object. What do we do with that reference? In this case, we are storing it into a variable called fourth. Okay, but this was one choice. Imagine we want to create, we have the powers of 7. We want to create the powers of any value. A table with the second powers, third powers, fourth powers of 5. So maybe I want to define a function for creating a table of powers, which takes as an argument the base and a function to compute the power. This function doesn't know whether I want to create squares or third or fourth powers. It will rely on a function that will compute the powers. So this is a function with the first argument will be a number, the second argument will be a function that will compute something about those numbers. For example, for maybe, let's print it from 1 to 10. I minus equal to 10, I plus plus. We can compute the power as a power function applied to base, and then print. So, if I wrote square here, it would be something trivial. a function that prints the squares, the 10, sorry, not, yeah, 10 times the square of the base. If I put a power function, it will be a variable that should behave as a function, and this function will be called to compute the power. So for example, when I call this table of powers, I can write the number 5 and the square. Square was a variable that points to a function. This function object is being given as an argument to this function, a function that receives an argument as a function. Okay. And uses this argument inside whenever they want to call that function. I don't know what function I'm calling. My caller is telling me that. But, okay. Okay, this 1025 means that 25 is printed 10 times. It's a console that's trying to compact and say, that's why it's like this, so we don't get confused by the, okay? So it's printing 10 times the base. And if we want to compare the 4 powers, we just call the same table of powers, which is not a good name, table of power, because just, okay, with a different function as a second argument. Okay, so we are defining functions as variables. We are storing them in variables, and we are passing them in functions. This is a way of generalizing the behavior of a function that do something with my values. It's the basis of functional programming. I have an array of numbers, do something with these numbers. And we are separating with the do with the something. So a function that has the mechanism for doing, but we want to specify what we want to do with these numbers. And what we ought to do in JavaScript is nearly always, I'm providing you a function to do that. I have a general operation that you want to do, but this operation is customized by a function that I'm giving you. Maybe some other times I'll give you a function that you must call when there's an error. A function that you must call when you need a new value. A function that you must call when you want to do some computation. So many times we are creating functions for instructing other functions to do what we want with our data. We can also do that more dynamically. Table powers with 11, and this time we want to make the, I don't know, the square root. We should define a function that computes the square roots and return a value. Okay, but why waste lines and variables? Just do that in line. So the second argument is a function, should be a reference to a function. I don't have a function that does what I want, I just create it in line. And it would be, instead of storing that to a variable and passing the variable to the function, I just created the value and passing the value itself. I don't store it anywhere else. I don't need it anymore. Why store it? And it works, I hope. Yep. With the square root of 11. Okay, we are creating a function on the fly and then passing this function to another function as argument in this case. By the way, there's an even shorter syntax, because right now we only have function that had one argument, function that had two arguments in this case, and they all of them can be written as arrow functions. But there is a special case. Let me copy this line. Well, actually, two special cases. The first one is when the list of arguments of an arrow function is just one variable, one argument, you can drop the braces, the parentheses. If you have 0 arguments, you must, of course, put them. If you have more than one, you must put them. If you only have one, you can drop them. And if, only if, the body of the function, that can be 50 lines of code, can be anything, but by chance, if the body of the function is just one statement, which is a return statement, you can drop the return and the braces. If we only have a return statement, drop the return and drop the braces. It's just return an expression computed from a single parameter. Of course, we can also have 2 parameters. In this case, they are independent, these shortcuts, of course, for the argument and for the return value. So this is a much shorter syntax. It will take a while because before we recognize this as a function definition. Okay, we need to train our eyes in the code because it doesn't look like a function here. Actually, we'll have a lot of them. Most of the functions we define probably will look like this. It works in the same way, of course. It's just a syntax shortcut. Nothing more. 1, 2, 3, 2, 10, and then the same again here. And this is interesting also when we combine that with objects. Let's take from the other file the person1, for example, here. Let me copy it here. After all mathematical computations, we have this person1 that, remember, let's remove this stupid. We had the address as a composed field, okay? Imagine I want to print the address of a person. I should put together the street, the city, the number, and so on in a given order. Why don't I give the object the notion of how to do that? I could put into the object not just some values, but also some functions that are able to process that object. For example, we could have an extra property called print address. It's an extra property of type function that contains the code to print the address. Of what? Of this object. So it could be a console.log of this. We use this keyword like we use normally. We will explain better how this works, but just we're making an example here. Street plus space plus this dot city, for example. Then we can make it more complex, but and then after I've done this, I can use person1 dot print address. Up to now, I have an object. I extract a property of an object. This property happens to be a function. the value of this property happens to be a function, so I can call it. When I call a function like this, in other language we call it a method, the object on which we are calling it is bounded to the variable this, which is normal in object-oriented programming, or self would be in Python. And so we, sorry, it's something wrong, undefined, it was not what I expected. Okay, this dot address. This dot address. What do you want? Street. Okay, well, I will debug it later. There's something wrong here. Okay, so but the idea, just because I don't want to be long, I will store the version, because I want to tell you one last thing before closing. And this is common, okay, to mix in an object some data and some methods or some function to operate on that data. Usually we don't do this like this, because what happens if I had person 2 to handle? Then I should define, okay, the values, the data are different in person 2 from person 1, but the methods, the function will be the same. I don't want to redefine the same function in every object, okay? So that's why we have the last type of functions that I want to tell you, because we are very useful. They are called constructor functions. A constructor function is a function used, a normal function, that is used to create a new object, to initialize an object with some templates of values. So by definition, or by convention, constructor functions are defined with a capital letter, C with a capital C, Parser with a capital P, by convention. And they are called not just a normal function, but with a new keyword. It looks like a class, okay? It's just a function. It looks like a class. And in this case, we are calling the function car by providing it a new empty object, and the function adds some properties to this object and some functions. The properties most likely will come from arguments, because they will be every time different. The functions will likely be the same. So in this case, what we would do with our person would be to define a function, a constructor function for objects of type person. So we are attacking one of the things that we had in the first 3 minutes, to say we have different objects with different properties. How can we be consistent? Well, let's create the object of some kind through a constructor function. That maybe takes the name, the last name, and takes the city and the street, the number and the code, postcode, for example. And capital P is a constructor function. When it's called, it will receive an empty object, and it needs to build it. So it will build that the first name property will be taken from the name argument. The last name property will be taken from the last argument, for the second argument. The other fields will be inside the address property. So it will be this.address, will be an object that is a street property taken from the street argument, and a city property taken for the city argument, number taken from number, and postcode from postcode. So whenever we call this, it will create a new object with this property put in this way, starting from the arguments that we give, arguments or some other source of information. So let me comment this, so that we don't clash it. And in this case, this person one could just be create a new person with this argument. The name, make it short, FC, the city is Turin, the street is Duca, and the number 24, and postcode 1029. Go away. And in this case, we can see that the object has been created by the function, person1, is the same object as before, first name, last name, address with the nested properties. In some way, you see that it's an object of type person, it's a loosely, it remembers the name of the function that created it. It doesn't have a real type, the type is object, but it remembers that it was created by person, by this constructor function. So you can construct many objects, they will all look the same properties. It's just a function. The new keyword is just creating the empty object that inside here is called this. And now, if I want to implement the print address, I can do that once. This dot add another property of type function. And now I can call on this person one this print address. So what happens is that this constructor function will populate an object with some properties depending on the data I give, and it will attach to all of them this same function. It will be the same, it will be reused across all the objects. So we are not creating this anytime we need an object. Okay, and we see that, where did it go? The debug console. In this case, the street and the city in this shortened version. It has been printed there by this function. But most likely we don't want the function already to print, but just to build a string. Okay, but it was just to give you an example. So what we are going to do in the next hour is just to play with this pattern, okay? Creating objects with constructor functions, creating functions that manipulate some objects, some list of objects, and so on, in order to, manage this, basic, say, pattern of object-oriented programming. Creating objects, managing properties, and having functions that work on objects and object properties themselves. Okay, it's 10 o'clock. Thanks for listening. And in the next hour, Francesco will be here in a moment. We'll make an exercise with you on these topics. Okay? Thank you.